Hi, I am Kazi Tamzidul Islam. I came here from Arkansas State University, and my project name is Use of Rice Hull Ash as a sustainable source of construction materials. And I am right now working with Dr. Hussein. So moving to the next slide. So this is my presentation slide, as usual, the introduction, background, objectives, and all the procedures I followed, and the test results and the conclusions. So talking about the introductions, rice hull ash is a residue obtained during the milling of rice. Right now, it's considered as a wastage material in the rice industry. Like as I already told you that I came from Arkansas, and Arkansas is the biggest rice producer state in the United States. And in the Jonesboro, where my university situated, there is one of the biggest rice milling company in the world, that is Riceland Food, and they produce millions of tons of rice hull ash each year, and they just dumped it beside in a landfill. So so our objective is to use this industrial waste as a sustainable construction materials. Moreover, is that we want to replace some cementous material with this rice hull ash, and adding to that, these ash have very bad impact on the surrounding environment, because it doesn't degrade so easily. So it eventually pollute the air, the water, and all the environment. So this is, I think, this is not that much new topics, and many researchers has already worked on that. And even from my team, Dr. Hussein and one of my senior also worked on that, and has published some of the research paper on that. And talking about that research papers, he worked with two different types of rice ash, and he has already showed that the coarser rice ash reduce the strength of the concretes. So the main objectives of our project is to evaluate the physical and chemical properties of RHA, CFA, which means fly ash, and SF means the silica fume, and to determine the properties of fresh concrete mix and hardened concrete after modification with RHA, CFA, and silica fume, and to determine the alkali silica reaction and the effect of de-icing chemicals of RHA, CFA, and silica fume modified mortar bars, which is we were thinking that we wanted to see how this modified concrete works in adverse weather conditions, like in the very freeze weathers, or if there is alkali in the concrete surface. So how this modified concrete will work. That is one of the main objectives of our project. So these are the materials I have worked with. So as the cementous materials, I consider the ordinary pottery cement, which is type 1, and we followed the absolute volume method for the mixed design of this modified concrete. And as you can see that there are 3 types of RHA. I distinguish them with RHA1, RHA2, and RHA3 according to the particle size of this RHA. RHA1, which is like 600 micrometer particle size, RHA2, which is 150 micrometer of particle size, and RHA3, which is 44 micrometer RHA size. So, and then this is the methodology I followed to conduct this the whole procedures. Like I collected the RHA from different sources, and CFA and SCW, then determine the chemical and physical properties, and then prepare the cylinders, beams, and all other stuffs with this modified concrete, and then test them and follow the basic concrete tests to see how this modified concrete shows. And at last I analyze and document test results. So these are the pictures. Even you can see that I'm working with some SLAM test in the pictures. And this is the fresh concrete test I have conducted. And these are the the curing I have done, and the compressive strength test, and the flexural strength test, even the tensile splitting test. And these are the Poisson's ratio test and modulus of elasticity. And this is the test setup for the ASR test, which is like alkali silica reactivity test. And mortar cube test I also done that. And for the scaling test, according to the ASTM, there is a specification that the scaling test should be done on the real surface of concrete slab. So apart from that, I conducted it on the mortar bars. And this is the specific surface area test. I followed the ANOVA analyzer to see how this particle, how the particle size, and I followed the BAT procedures for this test. These are the outcomes of my fresh concrete test. As you can see that the RHA1, which is the most coarse RHA, has the slam below, highest slam below, and RHA2 is less than that, and RHA3 is less than that, and followed by the CFA, and the silica fume is higher than that. So as because the finer materials, as got the final materials, the concrete mix gets more stiffer, so it will need more water to have the same consistency as the control sample. So if I add like finer RHA on the concrete with the cement, then it will require more water, and the slam below will be less. Same as goes for the air content, and unit weight increases with the finer RHA modifications. And the compressive strength test, which is like talking about the concrete quality, what comes to our mind is how the concrete, what is the compressive strength of this, the compressive strength of the concrete. And as we can see that the RHA3, which is 44 micrometer RHA, and CFA and silica fumes are showing the highest compressive strength for the 10% replacement of OPC, ordinary Portland cement. And if we go for the 20%, then it is a little bit less than the 10% replacement. And for the RHA1 and RHA2, which is the 600 and 150 micrometer RHA, the compressive strength get very much low, as because the RHA1 contains more carbon than the RHA3. So and we know that if the carbon content is it has adverse effect on the compressive strength. And this is the tensile strength test which I did, and it also followed the similar trend as the compressive strength test. And here also the finest RHA shows the highest result, and followed by the CFA and the silica fume as well. And also the 10% replacement is the optimum optimum result here. So this is the flexural strength test I conducted, and It also followed the same trend, like 10% for 44 RHA, CF and silica fume showed the highest flexural strength compared to the control sample. And I also calculated the estimated flexural strength using the SCI formula. It is seen that the laboratory test result is higher than the estimated results. And this is the silica, alkali silica reaction test. And from the graph, we can see that the RHA3, 10% RHA3 shows the less expansions in the alkali presence. And this also, like we can say that if there is alkali in the concrete surface, it will reduce the immature distress if we use this finest RHA in the concrete mix. And this is the de-icing chemical test. And we, as I already told that I did this for the mortar parts, but the specifications is for the whole concrete slab. And I also put these mortar bars in a freeze-thaw cycles, like for the 18 hours for the freezing temperature. Then for the rest of the hour is for the thaw cycles, and in the presence of calcium chloride to see how the de-icing chemicals affect these mortar bars. And there is a very interesting outcome is that the RHA3, which is the finest RHA, shows very less scaling in the concrete mortar bar surface. And I rated them. You can see from the graph that RHA3, CFA and silica fume has 0 marking on the scaling rating. And this whole cycle, there is 10 cycles of freeze thaw in this experiment. And this is the conclusions. From the conclusions, we can say that the coarse RHA should be grounded to obtain the finest RHA, and the coarse RHA should be avoided for the regular concrete. But we can use it for other purpose, like for the low strength concrete. Like if you can use it for the backfill concrete or the floor well, where we need a huge amount of concrete but a less strength concrete and more economical. So in that case, we can use that coarse RHA. And for the RHA3, CF and silica fume modified concrete showed improved concrete properties. And from the overall all the experiments, it was found that 10% replacement of ordinary Portland cement in the concrete is the optimum use, because if more than 10% is used in the concrete mix, then the concrete properties gradually decrease. And I would like to thank Tran-SET for funding these projects, and Arkansas State University and Riceland for supplying us the RHA and all other sources to give us all the samples to conduct test. Thank you all.